5.5, or try to. So horizontal and vertical asymptotes. Horizontal and vertical asymptotes is what we stopped talking about yesterday. Remember, those are our imaginary boundary lines of where our function is approaching. As you can see that examples A and B show you two horizontal asymptotes. Notice that it's y equals a value, a limit is what we call. So there's a limit for it. So we say y equals that limit. And then C and D are examples of our vertical asymptotes. Okay. Yeah, I think I showed y'all yesterday how I remember which is horizontal, which is vertical is with OI and VUX. I don't know why it came out like that. OI and VUX is horizontal, 0 slope, and it's y equals. VUX, vertical, undefined slope, and it's always x equals. So y equals a limit, x equal a constant, a value. Okay. Yeah. A little fact about your horizontal is that your function, there are very unique functions that will cross a horizontal asymptote. Okay. So there's no function that will ever cross a vertical. Okay. A horizontal asymptote, when it occurs, describes the end behavior of the graph as x goes to negative infinity or as x goes to positive infinity. Okay. And again, what did I just say? There are certain that cross it, right? So it may intersect your horizontal asymptote. A vertical asymptote, when it occurs, describes the behavior of the graph when x is close to a number, which is why we call it a C. Okay. Horizontal is a limit. C is a number, a constant. And the graph of the rational function never intersects. It will never cross a vertical asymptote. Okay. There is another type of asymptote, and it is also describing a limit. So as x is approaching negative infinity or positive infinity, and it's called an oblique or slant asymptote. Okay. An oblique or slant asymptote is a unique imaginary linear equation, linear line that the graph does not cross. Okay. And the graph may intersect in special situations, the oblique asymptote. So how do you find the asymptote, right? Probably is what you're thinking. How do I find that asymptote? Easy enough. When you're looking for a vertical asymptote, it is all based on your denominator, okay? Well, we talked about it being leading up to it. Remember, I said we're going to dive deeper into it. So looking for the vertical asymptote, it's all based on your denominator. What's happening in the bottom, okay? And yesterday I told you that it's either going to create a vertical asymptote or it's going to create a, anyone remember? A hole. Do you remember hearing that? Oh, yeah. Okay, it's either going to be a vertical asymptote or a hole. So we're going to go through these 4 examples. So we're going to start with example A. So example A, I do not need to factor the numerator or denominator, so I'm just going to focus on the denominator, and I have x minus 3. To find my asymptote, I'm going to take x minus 3 and set it equal to 0. And what do I get? X equals what? 3. So therefore, I have a vertical asymptote at 3. That's a simple one. Easy. Huh? X equals 3. Vertical is x. VUX. It's the VUX. Okay. So we end up with x equals 3 is our vertical asymptote. Okay. Let's look at B. So for B, we have x over. Uh-oh. I didn't want you to answer yet. We have x over x squared minus 49. This one, before I get started, I have to factor. So I asked myself, what multiplies to give me negative 49, but adds to give me 0? Well, that would be positive and negative 7. So when I set each one of them equal to 0, what do I get? Negative 7 and 7. So we have x equals negative 7, x equals positive 7. All right. C, example C we talked about yesterday as well. It is a special situation. Does anyone remember that special situation? If I set the denominator equal to 0, what do I end up with? An imaginary. And if I end up with imaginary, it's all real numbers. So that means there is no asymptote.
Wait, how do you know that?
If I solve for x, I end up with x squared equals -9. And can you take the square root of a negative? No. So we end up with no vertical asymptote.
So it's like, why would we just factor?
Because it's not a difference of squares. You can't factor. There's nothing that multiplies to give you +9, but adds to give you 0.
Okay.
And so there's no vertical asymptote. We get that? All right. And again, it's because I'm going to end up with an imaginary situation, correct? All right. Last D, we have x squared minus 25 divided by x squared plus 2x minus 35. Yesterday, we talked about this as an example where you need to factor the numerator and the denominator, right? So to factor the numerator and the denominator, x squared minus 25 becomes x minus 5 times x, times x plus 5 divided by what multiplies to give me -35, but adds to give me 2. What two numbers? Multiplies to give me -35, but add to give me 2. What kind of 7 and 5? -5 and 7. Okay, so this is an example of when you factor, you can remove. So because I can remove it, it's not a vertical asymptote. It's a whole. Do you remember this, what I said yesterday? If I can remove it, it's a whole. It's a removable discontinuity. So my only vertical asymptote is at x equal -7. So let's go through it a little more. So we talked about here, we had to factor, and we could. So we ended up with our 2 vertical asymptotes, right? On C, we couldn't factor, and we couldn't solve for x. So that means that there is no vertical asymptotes, right? And then on the last one, we had to factor the numerator and the denominator. So we factored the numerator and the denominator. What did we notice happen? They canceled out, they eliminated, right? So that means that they were wholes, and I'm left with x plus 7, and therefore my only, how did I do what? The denominator. So my only vertical asymptote is at -7, because at -5, it's a what? A hole. There's a hole in my graph. All right. How do we feel about the 4 examples? Good? All right. Let's talk about multiplicity and vertical asymptote. So remember, multiplicity is when we had the negative, the odd or even powers on our factors, right? So if I had x minus 2 squared or x minus 2 to the 3rd, those are my multiplicity. So if the multiplicity of the real 0 that gives rise a vertical asymptote is odd, the graph approaches infinity on one side in the vertical asymptote, and it approaches -infinity on the other side. So basically, it's saying that if I have an odd situation, this is my asymptote, right? So my vertical asymptote will be doing opposite things. So one will be coming this way, the other will be coming that way. Does that make sense? Okay, if I have an even multiplicity, an even situation, here's my vertical asymptote. They're gonna both be doing the same thing. Okay, so odd, opposite behaviors, right? Even, equal behaviors. Odd, opposite, even, equal. That's how I remembered. I don't know if that helps at all, but Okay. Questions, comments, concerns? Odd, if you have an odd multiplicity, they're going to be doing, so for example, if it said x minus 3 to the third, right? At 3, they're going to be split. So one will be coming and one will be going. Or if I had x minus 3 squared, they're going to be both heading towards 3. That's, remember, multiplicity is the little tiny number on your factor. Yes, now we remember for real this time. All right, let's talk about horizontal or oblique. You cannot have both, okay? You will have one or the other or neither, huh? Shut up. Do we really?